Welcome to the next video on in Blind 70. The last video that will be covering arrays and hash related problems 75. And this is the hardest problem in the section that you'll be going over, and probably the one that is asked most commonly in Google or Facebook interviews. So please pay attention to this one because this is a very common problem in. So generally speaking, in this question, we need to find the longest consecutive sequence given an array called array of integers called nums. Uh, we need to give that output. Consecutive sequence defined in this problem is a sequence of elements in which each element is exactly one greater than the previous element, basically. And our algorithm must run in time of n. So let's basically explain this problem a little. So if we have numbers, as you can see here, 2, 20, 4, 10, 3, 4, and 5, basically, right? So let's get that sorted out. So if we have number, then 3, we have this number. Basically, what we need to do is we need to find numbers that are consecutive to each other. So we have 2, 3, 5, right? We can add 2 and 5 as right. So we can create array and 5. That's the first consecutive number. Then we have then we have actually uh, then we have actually 20, 10, which are separate. So they're not new sequences. So what you need to understand at this point is that we have this particular longer sequence, and these as individual, but they're separate sequences that we can add. Based on that, how do we get to this point, right? How do we find the longest sequence uh, of elements in the array given to us? A simple way of work for us could be if we array from smallest and largest to run a sorting algorithm, and we would have something like 2, 3, 5, 20, 10, and 20. Generally speaking, you can have something like this. Just quickly writing this out because this is our solution for this. So once we have these values here through a sorting algorithm, we can just pull out consecutive values, label them, and get this done. But the issue is that any sorting algorithm runs at a rate of O n log of n, is not the timing that we need. This is an unacceptable amount of time based on this. And all sorting algorithms run at this rate, O log of n, n log of n. While we need to write an algorithm that runs in O n of O time of n time, basically. That's the algorithm we need to write. So this can never not be the solution that we need to solve this problem. So how do we solve this problem itself, basically? So if we go back here and let's write a couple of more simpler values out that we can use to explain this question. That is 100 for 200, 100, 132. 1, 3, 2. So what would be the best way to sort this out without using a sorting algorithm? So based on the prompt of this question, we need to first visualize this problem carefully, right? So we can best way, a good way to visualize this problem actually be if we use, if we use a timeline to sort this out. So let's draw a line here, and based on this line, let's basically define this. So we have how many sequences here? 1, 2, 3, 4. This is the first sequence. So we write this down here. 1, 3, 3, and so that is the first sequence we have from this list that we presented just above here. Then we have another sequence which is 100. Then we have another sequence here which is 200. Up this up here as well. So these are the three sequences we have for this problem, right? But how do we identify this if we want to keep the time requirements and the memory requirements n? That is the requirement we need to match for this problem. How do we make sure our solution matches this problem? Because sorting algorithms can't match that. So the one thing that we understand if we visualize this problem here is every sequence starts when there's no number less than when we minus one digit from that number. There's no that number does not exist in the sequence. So if we minus 1 from 200, 199 doesn't exist in the sequence. That's the start of the first of a new sequence. 100 minus 1, 99. 99 is not there, so that's the start of the first sequence. 1 minus 1 is 0. 0 is not in the array, so that is the start of a new sequence. So every sequence starts when there's no when we deduct one from each of those numbers. Uh, that new number after the subtraction is not within the array, right? That's the first thing. Now that we understand that particular aspect of our conversation, how do we identify the sequences themselves? So that is pretty much simple after that. So if we have one, for example, let's start from if we have 100 here, right, as the first element in our array. So 100 minus 1 is 99. 99 is not there, so this is the start of the sequence. We bring it over here, right? And once we bring it over here, then we need to see 100 plus 1 is a 101. There's no 101 in the sequence, so it's going to be an isolated number. So that is the complete sequence, right? That's one, right? Let me actually. There's no next number. So this is a complete sequence with n equals to 1, right? Similarly, if we check 4 minus 1, 3, this does not start a sequence, so we cross this out. Rather, I think it's better to see the number. So this number cannot start a sequence. 200 minus 1, 199, that figure is not there, so this starts a sequence. We bring it down and start the sequence. At the same time, 200 plus 1 is equal to 201. We don't have 201, which means just an independent isolated sequence. So we have that here as well, and the value is n this as well. Now we have 1. 1 minus 0 is 0. 1 minus 1 is 0. So 0 is not there, so this is the start of the sequence, as we can see, right? So it starts the sequence, but here. Similarly, 1 plus 1 equals to 2. 2 is within this group here, so we have 2 here as well. So we bring this over here in the sequence as well. 2 plus 1 equals to 3. That's another aspect of the sequence. Bring it to here. 3 plus 1 equals 4. That's here. We bring it down here as well. And we have all these values bringing in coming down to the sequence of 1, 2, 3, 4, where our value of n equals to 4. That is basically sequence and the logic behind this algorithm that we need. We need to find and identify the pattern through which we identify the start of the sequence, and then we check if the sequence has more numbers by checking those values. With that out of the way, I think now we can come back to the main question that we need to answer. We need to write down the code for this question next. So write the code for this question. We first need to start bringing our pseudocode in, but even before that, let's go over this problem in a scientifically curated manner. So to solve the longest consecutive sequence problem in time, we can leverage a set to store the elements and identify the starting point of each consecutive sequence. Now, there's another aspect I just wanted to add in the whiteboard here. We would potentially the value of the let's here a little bit value of these values. Once it is a set, we can easily identify values from a set. So we need to keep this make sure that the values of the array are saved as a set. That would make things so much easier for us to sort out. So with that out of the way, let's go over the problem again. So first we use the set to store all elements of the array, as you mentioned. This allows us O at the time of 1, average time to complexity for any lookups that we need to do. Then we iterate through each element in the array and check if the start of a sequence, an element is the start if there's no element smaller by 1, so we minus 1 as we discussed previously in the logic. And the element, if the element is start of sequence, find how long how long the sequence is by counting consecutive numbers starting from that element. That's the next thing we do by adding 1, and then track the maximum length of consecutive sequences found as we were doing when we're going over the sequence n equals to 4, n equals to 1, n equals to 1. Those are the values that we identified. So what would our algorithm potentially do? Store elements in a set for a fast lookup, iterate through an array for each element to check if it's a beginning of a sequence. If it is, it will iterate through possible consecutive elements, counting them, and keep track of the maximum sequence, basically. So first, let's start coding our array. And for that, let's bring our pseudocode that basically is the code we write at the start to help us guide writing the actual code within the program. Bring our first here. It is convert the list to a set for O1 lookup time. So to do that, we first create a list based on the value that is coming in. We have created the set, and then we need to also start a counter to see what the streak level for each of the consecutive numbers in the set are. That out of the way, let's bring in our next pseudocode, which would guide us over the next part of the code that we need to go over. Create some distance between the pseudocode of first step and the second step. Now we need to create iterative each number in the array, and the best way to do that is using a for loop. That out of the way, we have another pseudocode for sub pseudocode for logic in our in our uh, in our for loop, basically. So we copy that pseudocode over here, and then we write our code as needed. So first we need to check if a number, if we deduct 1 from a number, is that number not in set? If it is not in set, we need to set that as the start of the sequence. So let's write the code for that. We're checking if num minus 1 not in uh, that not in the num set. Once we have checked that, then we need to create a new variable current num that records that number as the start of the streak. and add 1 to the current streak value. With that out of the way, we'll bring our next pseudocode over here, which would guide the next part of our code writing. So we bring that down here and we print that, paste that down. And now we need to work on our next piece of pseudocode. Let's bring it down here. It's needs to be out of the if statement. Then we need to write check for the length of the sequence starting with that num. So while current num, we'll basically write down the method where we checked if the current num adding +1 value to that current num and is that value in the num set. If so, we add the current number to current number by 1 and current streak by 1 as well. So let me write that down. We're using a while loop here because we need to keep this process going until we can't find any number which on addition of 1 on the current number is not. If by adding 1 in the current number we can't find that number in the set, then only then we need to stop this process. So that is why we're using a while loop. With that out of the way, now we need to bring in the next piece of pseudocode, which is going to guide our next piece of code. And we're almost at the end of this program now. So then we need to update the longest streak that we were in, right? And that is basically we check for the longest streak, compares longest streak with the current streak and see which one is biggest. And if among them whichever is biggest is saved as the new longest streak. So let's do that. That out of the way, we now need to return the value of the longest streak from the function. Before we test this code out, basically we need to understand that we convert the input list to set for fast lookup times. Then we deduct 1 from number and check if it is not in the num set to ensure that we only start counting from the beginning of a consecutive sequence. We use the while loop to count the length of the consecutive sequence and then using the max code that we use at the end, we're identifying the longest sequence. Time complexity for this is ON, and the memory complexity for this is also ON. So it completely fulfills the requirements for this project that we need to have. When we run this code, it worked. Both of the cases passed, and that is how you solved the hardest problem in arrays and hashes, blind simplified problems called longest consecutive sequence. And with that, we're going to wrap this video up, and we'll see you in our next video. Thank you.